In this video, we're going to take a look at real numbers and numbers on the number line. In order to do this and to kind of introduce this topic, just a quick review of square roots, okay, and perfect squares. Remember, a perfect square would be a number raised to the second power is 1, 2 raised to the second power is going to be 4. Sometimes I think too much ahead. 3 squared would equal 9. 4 squared equals 16, so on and so forth. These numbers are what are called perfect squares. Okay. When I deal with square roots, it does the inverse of squaring something. So if I take these numbers here and say the square root of 1, square root of 4, square root of 9, the square root of 16, it is a way of getting back to my base, the 1, the 2, the 3, the 4. Okay. By way just of introduction vocabulary, this is what's called the radical side. The number underneath it is what's called the radicand. So the radical sign plus the radicand, okay, the number inside of it, make up what's called the radical. Right now, if there's no what's called an index written here, it's assumed to be a 2, okay, which would denote basically a square root if it is a 2. Okay. So if I want to take the square root of a number, okay, if the number is a perfect square, like the square root of 100, well, I know that 10 squared equals 100, so the square root of 100 is 10. Sometimes they do not come out as evenly, or very evenly, so I might say, what's the square root of 21? Okay, I would have to think about a number line. 4 squared gives me 16. 5 squared would give me 25. If I think about 21, 21 falls right in the middle of these. So therefore, I might say it's 4 point, well, let's see. It's 5 values away from 16 and 4 away from 25. So it's probably going to be about 4.5, maybe 4.6, I'll say. I'll say that it's approximately 4.6. Okay. It's always about an approximation, but in relation to what are the two perfect squares that fall closest to this. It introduces the whole concept of kind of categories, or what are called sets of numbers. Okay. Overall, pretty much everything we're dealing with the exception of the square root of a negative number, is what's called a real number. Okay. When I'm dealing with a real number, I can break it down into two categories. It can be what are called rational numbers or irrational numbers. Irrational numbers are numbers where the values don't come out evenly. It's not a terminating decimal. It's not a repeating decimal. It's nothing that can be written as a fraction. So, for example, the square root of 10. Okay, the decimal is kind of crazy. Okay, and it keeps going and going and going. Pi would be an irrational number. Negative 3.6154316, okay, keeps going on and on and on without repeating or without terminating ending. And it can be positive or negative with the irrational numbers. Rational numbers are always numbers that can be written in the form of a fraction, a over b. So for example, 1/4 would be a rational number. Negative 0.3 repeated, which really is equal to 1/3. Negative 1/3 could be a rational number. Okay. From rational numbers, I break it down a little further, and I get a set of numbers which are called integers. Okay. These include values, both positive and negative, -10, -2, it could be 1, 2, 5, it could be the negative square root of 16. Okay. These are all classified as integers. I can go a step further and say something's going to be a whole number. Okay. These could be the values of starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, or what are classified as whole numbers. And then I go to the kind of the innermost category and say something's what's called a natural number, or it's also sometimes called a counting number. And this is the 1, the 5, okay. I could do 4 halves, which is really equal to 2. It could be the square root of 25, which is really 5. So these are all things that come out to be whole numbers that are greater than 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now one thing that's important to note is a natural number is also a whole number, is also an integer, is also a rational number, is also a real number. The only difference between a natural and whole number, so the only natural number that's the only whole number that's not a natural number is 0. For integers, integers add the negative numbers. Okay, negative whole number, or negative are the opposites of the whole numbers. The rational numbers start to add the fractions, the terminating decimals. 1/4 would be 0.25, as well as the repeating decimals. So negative 0.3 repeating is the same thing as negative 1/3. Everything can be written as a fraction for rational numbers. Okay? All these fall underneath the category of real numbers, but real numbers also include irrational numbers, things that don't really come out evenly, or kind of really, you get a lot of really strange decimals. So these are sort of the sets of numbers. Okay. So the set of numbers is the larger category, and then the subsets are things that are broken down. So when we think about the set of real numbers, okay, we have the subset of rational, integers, whole numbers, natural, irrational. Okay, it kind of breaks down this into these subsets. When I want to order real numbers, it's important to think about where things fall on a number line. And many times the best way of doing this is actually just to convert it all to decimals and think about where about they fall underneath the number line. And a lot of times we'll use in an inequality a greater than sign or a less than sign to show where about they actually fall. So hopefully this has been helpful, and good luck.